In this video, we're given a function and we want to classify the critical points of the function as either relative maximums, relative minimums, or saddle points. So let's begin by finding the partial derivatives. So the partial derivative of the function with respect to x will be 2x plus 2y minus 2. The partial derivative with respect to y will be 2x plus 4y plus 4. The next thing that we need to do is to set each one of the partial derivatives equal to 0. Essentially what we have now is a system of two equations in two variables, which we need to solve for x and y. The easiest way to do that will be to begin by rewriting this in standard form for a system of equations. And let's eliminate the x's. And we can do that by simply subtracting the two equations. So if we have 2x minus 2x, we have 0. 2y minus 4y is negative 2y. 2 minus a negative 4 will be 6. Solving this for y equals negative 3. Next, we need to solve for the x value. So we can go to either one of our original partial derivatives. I'll take the first one, 2x plus 2y minus 2 equals 0. Substitute y equals negative 3 in for the y. And now let's solve this for x. 2x minus 6 minus 2 equals 0, or 2x equals 8, x equals 4. So we now have our x value and our y value. In order to find the z value, we need to go back to the original equation and substitute the x value and the y value into the original equation. Once we do that, we are going to end up with a z value that is equal to negative 10. So our answer as an ordered triple is going to be 4, negative 3, negative 10. And that's the way we want to write our final answer. The next thing that we need to do is to test to see if this is a relative min, a relative max, or a saddle point. To do that, we need to go to the Hessian, which I will start doing in green. So the Hessian, remember, h equals the second partial derivative of x times the second partial derivative of y minus the mixed partial derivative squared. So we need to find the second partial derivatives of each of these functions. So the first partial derivative, let's go back to here. And find the second derivative of that. The second derivative, f sub xx, will be equal to 2. Finding the second partial derivative of y, that will be equal to 4. And then the mixed partial derivative, and remember, it doesn't matter if you do f of xy or f of yx, they should both be the same. So if we take the partial derivative of f of x with respect to y, we end up with 2. If we take the partial derivative of y with respect to x, we would also get 2. Putting these together in the Hessian, we have h is equal to the 2 times 4 minus 2 squared. So h is equal to 8 minus 4, which is 4. What we're really interested in here is the fact that this number is positive. That number is positive. We have a relative maximum or a relative minimum. To determine whether it is maximum or minimum, we have to go to the second partial derivative of x, which is 2. And if the second partial derivative of x is positive, if f sub x is greater than 0, then we have a minimum. If f sub xy is less than 0, we have a relative maximum. So in this case, we have a positive 2, and so we have a relative minimum. So in conclusion then, we have a relative minimum at the point 4, -3, -10. And that's that problem.